It is now my pleasure to introduce our presenters for today. We have Derek, aka Duff, and Josef from the NRC. They both bring extensive knowledge and experience in the aerospace sector, and DAIR is very grateful to have you guys both here to present on some key topics that the NRC is working on. So, Derek and Joseph, thank you for being here. I'll now turn it over to you.
Awesome. Thanks very much. I'll just share my screen here. That should be coming across now. So I think probably want to start with just allow Josef and myself just to do a quick introduction of who we are. Josef, if you want to go first.
My name is Josef Eiblmeier. I'm currently the technical lead for the AD-Astra program. My background is I'm an airworthiness engineer, aerospace engineer, and have been before the current position. I've been head of airworthiness for the National Research Council in Ottawa here.
Awesome, thanks. And my name's Derek Gowanlock. Everybody calls me Duff. Please call me Duff. I came to the NRC just over 10 years ago, started out as a research flight test engineer, and then started leading our full-scale autonomous rotorcraft program, and have been doing full-scale autonomy for about a decade, and then recently appointed as the program director for our new drone innovation hub, which I'll be talking a little bit more about today. Before coming to the NRC, I had 28 years in the Royal Canadian Air Force, doing a bunch of different things, but largely flight test of jets and helicopters over a few decades. And so with that, we'll maybe jump right into the presentation. It's a real pleasure to be able to present at this session, and Stephen, thanks so much for the opportunity to present. Great partnership building here, and look forward to future great things to come. So it's our pleasure between Josef and I to talk about a couple of initiatives that have been created this fiscal year within the NRC Aerospace Research Center, focused around defense initiatives. There we go. So just a couple of moments. Forgive me while this slide builds. A couple of words on who the NRC Aerospace Research Center is. We're a grouping of researchers, capabilities, and facilities that focus on the aerospace ecosystem, crewed and uncrewed, of all types. Overall, our mission is to support the ecosystem to be competitive in Canada and internationally. We also develop technology both for industry and government, and we also support government in policy decision making, that sort of thing. Overall, as you can see, our vision is to have a safer world through smart, sustainable flight. Within the Aerospace Research Center, our overall priorities, the two main ones are sustainability and safety, and drones and autonomous flight. Those are sort of the things that are in our long-term strategic plan, and those are two massive pillars. Obviously, I'm sure everybody's aware, massive pillars within the aerospace ecosystem around the world. These are the emerging things that Canada obviously has a ton of investment in, and will be high focus around the world for the coming decades, likely. We also have a large effort focused on defense capabilities specifically, more as an application space rather than a technology space. But we have done over the last many decades a lot of work for the Royal Canadian Air Force as well as other services within Canada, and that will continue to be an emphasis. And then also, of course, we have a specific focus on productivity, especially around digital twins and virtual testing, certification by analysis, these sorts of things, as well as more efficient manufacturing capabilities. So within aerospace, we are organized by laboratories, and we had 5 until about 3 months ago when the Drone Innovation Hub was announced. And so we have an aerodynamics laboratory that looks at subsonic, supersonic, trisonic, wind tunnels, that sort of thing, computational fluid dynamics, etc. If anybody's ever driven to the Ottawa airport, you'll see the big wind tunnel, 9-meter wind tunnel on our campus at Uplands. And so a bunch of it's there, as well as downtown Ottawa. We have a lab focusing on aerospace manufacturing, and they're physically located in Montreal. We have the Flight Research Lab, which is the hangar you see, the big white hangar you see when you drive into the, just before you go into the parkade here at the Ottawa International Airport. We have a lab focused on propulsion and power, previously called the Gas Turbine Lab, but now expanding out into electric, hybrid hydrogen combustion, et cetera, et cetera. And then we have a lab focusing on structurals and materials performance, also here in Ottawa. The latest add is the Drone and Flight Autonomy Lab, which has facilities being built both here in Ottawa and in Montreal. And we'll talk more about that in a moment. And so from a defense innovation standpoint, as this emerging requirement over the last, or discussion over the last year with the defense industrialization strategy from the federal government, we've sort of been focusing mainly in three areas. So platform sustainment and decarbonization from a defense standpoint. We have a number of activities going on there. Won't touch too much on that today, but can certainly answer questions at the end if there are any. We have a focus looking at operational capabilities for defense. And so that activity is largely focused on crewed platforms. And I think that this has relationships to what Josef will be talking about a little bit. And then we have the drone and flight autonomy piece that I'll cover off in a few moments. So we've been working in this space obviously for decades and decades, and have had a number of past successes. And as we look at the growth and the implementation of new activities within the Aerospace Research Center around defense innovation, it's building upon these activities where we've seen good outputs and delivered solid capabilities to defense and to industry. And so there's a number of things listed here. I won't go through the whole slide detail, but ultimately just to say that as we looked at the challenge of how do we help defense industrialization, it was largely built upon the shoulders of giants that went before us who had strong success and sort of continuing to grow that into the capability that is the Global 6500 that Josef will talk about, as well as the Drone Innovation Hub. So when we look to supporting defense innovation, there was two announcements made almost 3 months ago now, but had been in planning for much longer than that. And listed right at the bottom of the chart here, we were allocated from the federal government almost $900 million for aerospace writ large, but the two biggest chunks were the things that Josef and I are here today to talk about. One is nearly just over almost $500 million of investment in a defense aircraft platform. And then just over $100 million investment in the Drone Innovation Hub. You'll note that the aircraft innovation is a 5-year duration project. Josef will talk about that. On drone innovation, it's a 3-year with some additional growth planned, and so I'll touch on that a little bit more. Ultimately, though, the idea around this investment is following along the PM's often quoted line, build, partner, buy. And we're very much focusing on the build and the build in Canada. It's about helping industry commercialize technologies for defense and security procurement within the Department of National Defense, as well as export of these technologies. We also partner, and certainly when the Prime Minister talks about this, he thinks about it from sort of how government acquires things. We interpret the same language, but we look at it a little bit differently from an NRC standpoint. And so partnering is all about partnering with our allies in terms of research and technology development. There's places where it's very appropriate to partner with our allies to get a higher level output for the government. And so we still do that with our allied nations. And then from a buy standpoint, the interpretation of this this language within the NRC is that we buy, as we acquire technologies, equipment, I should say, not necessarily technologies, but equipment, airplanes, for example, and Josef will touch on this, we buy Canadian. We don't, unless it's not available in Canada, we don't look outside the borders for the things that we acquire. So I'll talk probably about 10-12 minutes on the Drone Innovation Hub, and then I'll turn it over to Josef to talk about Ad Astra and the Global 6500 program. So as I mentioned, I'm the program director for the Drone Innovation Hub, and that's all about how we deliver capabilities and impact for industry and for defense. I have a colleague, we sort of share the overall Drone Innovation Hub leadership together. His name's Charles Vidal, and he's the Director of Research and Development of the new lab. And so I look at the impact and the output. He looks at building the capabilities within Aerospace Research Center, as well as partnering on facilities and capabilities sort of across the country. We look to build relationships and work together in other hubs so that we don't have redundancy where redundancy isn't appropriate. So in terms of the overall outlook, as I mentioned, it's a three-year activity. Our broad vision is to build upon the areas where we are global leaders in drone, counter-drone, and autonomous flight, because there are areas where Canada does have world-leading capabilities, and we want to increase that, see more leadership from Canada in these three categories. And I should note, when I talk about the Drone Innovation Hub, and even just in the name Drone Innovation Hub, we are including drones, obviously, so uncrewed aircraft systems, but we're also including that simple name, counter uncrewed aircraft systems technology, so counter drone technology, as well as autonomous flight technologies. And so we use the term drone just because it's easy to say, but when I use that term, especially in this briefing today, I'm including all three of those elements, because that's sort of the core focus of our capabilities. Also, I'll talk about defense as sort of the output that where we look to have ultimate impact. And when I say defense, I actually really mean defense and security, because included in that sort of ecosystem, we include the RCMP as the Federal Police Force, CBSA for Border Technologies, and we also include at the provincial level the Ministries of Natural Resources, specifically around wildfires and forest fires. We sort of corporately, we interpret that as a strategic security challenge, and so that's sort of included in the mandate of DIH. Objectives you can see here, we want to obviously develop technology across the board, deliver facilities that are secure for ecosystem use and industrial use in particular. We want to develop and accelerate commercialization, and also build the knowledgeable workforce in Canada. So those are some of our key objectives. It's the success metrics you see listed here. This is a sort of a capture of many of our metrics. And these are really leading indicators. They're not actually the end success metrics, but we want to identify those things that we monitor right now. Without getting into the detail of all these things, I think the one thing we wanted to share or highlight is that within the Drone Innovation Hub, we're very much oriented on industrial success, commercializing Canadian technologies. And all of our metrics, not only the leading metrics, but the metrics at the end of the program, are all based on industry success. We get measured by industry successes, not by the number of patents that we create or the number of papers or conferences or whatever IP that we generate. This is about helping industry in the defense sector to be successful. And so hopefully this resonates throughout the presentation, but it's certainly our fundamental objective. And that is a little bit unique within the NRC, even working with those that have worked with the Aerospace Research Center in the past. We would maybe look to collaborate with industry and sort of look at what industry's objectives are, like a given company, and what sort of strategies we would have at the NRC. And when we look to collaborate in the overlapping area where those Venn diagrams intersect, that's a great recipe for collaboration. But within the Drone Innovation Hub, it's very much more looking at just what does industry need? How can we help industry succeed? And that's really what that makes up our strategy. So within the program for the Innovation Hub, sort of like the kinds of impacts we want to have, it's really I have to get a new analogy for this, because I always say a three-legged stool, and that's a little bit unstable. So I got to find a better triad analogy than a three-legged stool, but basically focusing on three elements. So first is defense R&D. We have done and will continue to do direct support for research and technology development for the Air Force, the Army, the Navy, Joint Forces, Special Forces, DRDC, which is the research and development arm dedicated for national defense, as well as our security partners. We have great impact there. We will continue to do that. as we go forward with the Drone Innovation Hub. We also have a long history of supporting industry, and we will continue to do those things. Largely, the support industry that we've done in the past is very much one-on-one. So a given company will collaborate together to support technology development, to do some research and development services, maybe some experimentation, maybe some integration. And we'll continue to do those things. On that one-to-one space, we're also adding a few new activities. So first of all, as we build our facilities in Ottawa and Montreal, we're creating innovation space for industries, partners to come and sort of work and live and eat with us in our facilities to help accelerate timelines and make us move faster. And that'll be both here in Ottawa and in Mirabel. We're also looking at reducing the barriers to access. For those SMEs, in particular, worked with the NRC and the Aerospace Research Center, you know that we have been traditionally quite expensive, and we've realized this for decades. We've worked with the IRAP arm of NRC to help reduce that through the certificate program, and it's been generally successful, but we want to do more than that. And so we're investing effort and planning right now to find connecting funding sources that exist into reducing that barrier to access, to make it more and more inexpensive to work with us, and therefore help enable success overall. And then finally, this increased ISC participation, a little bit more of a niche thing, but it's something that we've heard from industry many times, as well as from defense. As the Innovative Solutions Canada program and challenges roll out and companies are selected, there's always a percentage, and it's not always a small percentage, of companies who are successfully selected, but who are not picked up and matched to a government partner. And so these opportunities for the selected companies, they kind of die on the vine. And so as we grow our team here, we are dedicating a certain amount of our capacity, our researchers' capacity and engineering capacity to find those ISC opportunities where there is a successful industry partner, but nobody has picked them up on the government side. And so we would add capacity, because oftentimes that's the problem. Like, you know, the Royal Canadian Air Force within the armed forces don't have the capacity to do this ISC. Well, we would help them with that by dedicating our own resources. And sometimes it's also a technology issue where they don't have a competence in a specific technology. And so we're going to help with that, so that all these ISC challenges that are presented, and there's going to be more going forward because it's a very successful vehicle, we'll make sure that those all get connected, that industry gets the opportunity to develop their technology with the funding that ISC provides, that defense gets the benefit of delivery of these technologies. And then from an NRC standpoint, we get to know the ecosystem better, because there's no better way to learn than working with companies directly. And so that's a great opportunity for us. So those are a few things, a couple of ads that we're doing around supporting industry, but that broad activity space of working with industry, sort of company by company, is something we will continue to do. Has been successful in the past. It's going to be needed in the future, without doubt. Probably the biggest thing that we're adding, though, from the Drone Innovation Hub and the ecosystem perspective is industry or ecosystem-wide activities. So we've not done this in the past. This is new for us. We call them marquee activities, and the intent with each of these, and I have 5 here that I'll briefly touch on, but there's more sort of in works as we go along the timeline. The intent here is to create opportunities that are available for many partners within industry, you know, tens, dozens, 20s, 30s at a time kind of idea, to help everybody's, I guess the analogy I would use, like allow everybody's boat to float, not just onesies and onesies. So I think starting off with Aurora Edge, and Edge stands for Experiment Development Gateway Event. This is probably the ecosystem-wide activity that's had the most positive feedback, most interest generated. And we started out with Aurora Edge being looked at as an annual experimentation activity that the NRC would create and coordinate and set up. And it would be oriented for technology development and demonstration, TRLs, or technology readiness levels, 4, 5, up to 7 to 8. The experimentation event would move around geographically, so east, west, central, north, sort of based upon, in particular, what defense focus is. And the experimentation would be planned with an underlying concept case, implementation concept or vignette or scenario sort of underlying what we would do. And that would be defined by D&D. And that would also be linked to focus that D&D have would be to commercialize or to select commercialized products. And so that might be linked to procurement plans directly, so that there's sort of a pathway there, or it's linked to other experimentation that would be linked to procurement. And that other experimentation would be like high TRL operational assessments that they would do following on an edge experiment. And that's sort of the G in that acronym, that gateway effect. And so the intent is to put where we started out looking to put these on annually. Essentially, we would set everything up, all the enabling capabilities, and then invite industry to come and participate. And there'd be no cost associated with coming to with the experimental activity. That's all covered by the government. At the moment, the only cost would be sort of the travel expenses to bring folks into the test location, but we're also working on finding funding for that. So this is an evolving concept. So I guess ultimately stay tuned for more. There'll be a little bit more information on that. But much like the reduced barriers to access, we're trying to make these activities as inexpensive as possible, so that the money invested in industry is allocated to the product development and its commercialization, and not having to fund these other things. I've said a couple of times, we initially planned this to be annual. The feedback both from industry as well as defense leadership and our own leadership is great idea, love it. Annually is too seldom. We need to do it much more than that. D&D is going to have a ton of requirement in this space, and so they want to leverage these opportunities frequently throughout the year. And so as we start our first opportunity in September, our first Aurora Edge, it's a bit of a small scale effort just to sort of understand all the complexities that we need to work through. But after we get through September, we will accelerate on how many times we present an edge event and location and all that sort of thing. So that's a big effort, and we'll definitely communicate more on the details separately. Obviously, only so much time today to talk about a lot of different activities. Next is the Maple List, and for those that are familiar with the American Blue List activity, it's essentially a qualification/risk assessment process where there's a bit of a oriented towards uncrewed aircraft systems specifically and their subcomponents. And the idea is to have some kind of standard, some qualification measurement that's independently done, as well as a cyber assessment, importantly, probably one of the most important aspects of it, as well as a supply chain assessment to ensure that there's an acceptable supply chain arrangement, that we're not procuring systems, or we're not qualifying systems that have supply chains that link back to named countries, for example. And so the Maple List is a listing of UAS systems and components that have gone through the process and sort of have the check mark kind of idea. In the US, the Department of Defense can only procure systems that are on the Blue List. So it's like a pre-qualification before procurement can happen. This is the intent with the Maple List within Canada as well. For those that have tried to get on the Blue List, it's very expensive, and the DoD makes it, and I think, if I could say frankly, they only allow so many international partners to come in onto the Blue List. And so with the Maple List, we were looking to break that barrier down and have our own qualification process and create this list based upon a standard that is harmonized with the US standard. And so it would open export opportunity. And same for Europe. European countries, European Union are looking at a similar arrangement. And so with harmonization across the board, it would just open things up overall. Switching gears, and I know it's coming fast. Happy to answer questions or have additional follow-up afterwards. National Framework is really a working group collaboration activity around experimentation. So we've thrown out this idea of Aurora Edge. We've coordinated it with Defense, and have come to learn that there's many different opportunities that Defense puts on around experimentation. And so the National Framework is, the idea here is to set up a coordinated approach that is publicly visible, so that industry can have a look and see what opportunities exist, when they are, and who to talk to about getting access to. And so Aurora Edge would be one thing on there, but Department of Defense National Defense has a number of other activities, and we would try to make those a little bit more public and accessible. Not own those activities at all by no means, but just to be a coordination place. Moving quickly up to the top right there, the Borealis. I need to update the slide, actually, the UXS dish. So the Defense Innovation Secure Hub for uncrewed aircraft systems, land systems, and maritime systems, hence UXS. There's been an RFP, proposals were accepted. There's been a selection. It's been approved by the minister, but it just hasn't been publicly announced. The UXS dish, especially on the air side, there's a lot of similarities with the Drone Innovation Hub, and there's a lot of questions that we get asked all the time about what makes these different. And sort of fundamentally, the idea is that the dish is private owned, private operated, and the agenda, like the R&D agenda, is set by industry, whereas the DIH has different capabilities that are mutually lined up with the dish. But it's obviously, government owned, government operated, and the priorities are set by defense directly. And so we just highlight on this slide that we are actively integrated with the dish and sort of have a harmonized approach overall, so that the ecosystem gets the benefit of all of that without a ton of redundancy. And then finally, the double acronym there. So AGRA stands for Autonomy Government Reference Architecture, and COE is a Center of Excellence. So the AGRA, the Autonomy Government Reference Architecture, is a standard for autonomy interoperability, sort of like from a teaming standpoint, especially teaming large drone systems with smaller drone systems. It's something that was identified or created within the States, but it's been identified within the Five Eyes countries, so Canada, US, New Zealand, Australia, and the UK, as a core interoperability framework going forward for these systems. At the moment, there's only a portion of this standard that's publicly accessible. Some of it still remains not openly releasable. And so our intent is to build a capability around this to help industry comply rapidly, given that the rollout of the actual standard is moving relatively slowly. We want to make sure that industry has an ability to be aware of what this standard is and build systems that would be interoperable in future, so as to not to what would be the phrase, like delay adoption or interoperability in the future with the product. Yeah, so that's just a broad overview of the program, and knowing that I'm running out of time here because I love to talk. I'm sorry, Joseph, you should have gone first. We talked about that in advance. I will accelerate. This slide, there's a lot of things going on. The core message here is that our focus within the Drone Innovation Hub is there will be some academic collaboration for sure, but the main focus is on TRLs 4 to 7 and 8. Looking at integration, experimentation through simulation all the way to flight, experimental activities, etc. And then finally, just maybe a couple minutes on the physical aspects of the Drone Innovation Hub. Our two labs, or two facilities. So we have the DFAL lab, so the Drone and Flight Autonomy Lab. Charles is the new director for that facility, broken out into two centers, one in Mirabel, one in Ottawa. At Mirabel, it's the Center for Drone Innovation, and it's looking at Class 1 and Class 2 using the NATO definition drones. So like from the very smallest drones up to 600 kilograms ish. And the center there is building new buildings, purchasing equipment, and developing capabilities that are sort of very expensive and challenging to find nationally, like they don't exist nationally and are hard to find even internationally. So the NRC looks to create these things and provide industry access to them because they're likely too difficult or expensive to build on industry's own. And then here in Ottawa, where I work or where I live, is the Center for Autonomous Flight Systems. So this is the Class 3 drones are being focused on here. So MQ-9, if the Air Force goes with a collaborative combat aircraft, that would be, experimentation, research, and development would happen at the Center for Autonomous Flight Systems. And we also maintain a fleet of or platforms that are autonomous rotary wing and soon to be developing a fixed wing capability to help support industries and academic development in that space around full-scale autonomy and complex autonomy teaming, but also to be used as surrogates for activities in the future. Oh, and one more before I go to the slides. So just a couple of examples of the capability. I talked about the autonomous platforms, but for the smaller drone systems, just a couple of capabilities that are included in this that are kind of unique. An indoor flight arena that is RF shielded so that you can do electromagnetic warfare testing within a shielded facility safely without having to go very, very far away. Very unique. Not many of those facilities exist in the world, let alone in Canada. There are none. And as well as things like a wind wall with a moving platform. So an 8 by 8 meter wind wall with thousands of fans that can all be actively controlled to create whatever kind of turbulence we want with a moving platform underneath. The first uses we see of that is drone ship interface. So how you do land drones on ships, but it also supports development around urban flight operations with smaller drones, that sort of thing. Yeah, so I think I'll transfer over to Josef. I did mention, just as I changed through the slides, the Drone Innovation Hub, the scope that I've described here today, will have complete by 31st of March 2028, and we should hear the good news hopefully in the next few months about additional support to add additional capabilities out to 2030. But that has not yet been approved, and we're still waiting for that final approval. So without further ado, Ad Astra. Over to you, Josef.
Thank you very much, Duff. Thanks for doing the introduction and also getting a bit of an overview how we are going to work in the future and how we're going to support the Canadian defense industry. So Ad Astra is a new initiative, and Ad Astra basically is the Advanced Defense Airborne Science and Technology Research Accelerator. It's quite a mouthful. So what it really is a 5-year, approximately $460 million Canadian initiative. And that includes the purchase of a new aircraft and modified aircraft to serve as a defense research platform for the Canadian industry. I mentioned here the word Canadian a number of times as a statement here, but it's important, I think, that this is going to be a Canadian aircraft. It's going to be modified in Canada for the Canadian industry, defense industry, to make him successful. And so the vision really is here to position Canada again as a leader in defense innovation. And how we're going to do this thing is sort of the accelerating technology and integration with the Canadian Armed Forces. There are around, I believe, around 580 defense companies in Canada. It's quite amazing how many they are. And I think it's important to make sure that we've developed them, we help them, to work with them, to get the visibility and the traction they are deserving. Quite often we hear things like, oh, it's easier for us to go to the United States, to go to abroad, and versus selling in Canada, making the Canadian defense industry, Canadian Department of National Defense aware of what we can do. I think we want to change that. We want to change that the Canadian defense industry is working to support the Canadian Department of National Defense and is also successful externally for the in the defense market. And that is particularly important in terms of Arctic defense. And as you have seen just yesterday, the new submarines is Arctic defense. I think that is something particularly important for Canada and what we need to work towards it. So the objectives, really we have 4 objectives here. The first thing is to enable the Canadian defense industry to demonstrate to the Department of National Defense their technology, what they can do, the proof of concept demonstrations. So with that I mean is not just on a workbench, but actually in an aircraft demonstrating really in real time, in real life, in a real scenario, what the technology is capable of. Currently, this platform is lacking because having an aircraft, an operating aircraft, is very expensive. And so our idea really is here to have this aircraft, make it available to demonstrate that. That is also then the next objective is to accelerate the development. Nowadays, development cycle in defense industry, like for example, drone technology is measured in weeks or months, not longer years. We don't have the time. So we need to work with these companies to allow them to accelerate their transition, what is new and exciting technologies into operational readiness for the Department of National Defense. And that means also for D&D to provide an early input when a product is developed. So to avoid a situation where the industry is developing their perfect product and then D&D, as for example, has other requirements. I think that is where the advantage is coming in. Now, with that is also establishing directly the connection early on. If there's an exciting new technology, early on the connection between the Department of National Defense and the Canadian SMEs, the defense industries. So there's a link already there, which hopefully leads them down the road to a successful product for Canada, but also internationally. And that would then lead to a fostering not the defense market for the export market. Ultimately, again, as Duff already mentioned, it's to foster the Canadian industry, to make them successful in Canada, but also in an export market. So how do we measure the success here? So some of the three of them, what we have here, we have more than that, but the idea really is to have 8 new tested technology to which can be developed in extreme environments, Arctic and cold. In Canada comes opposite to mind here. We estimate or hope to have 15 Canadian firms as a minimum engaged in the development of technologies, and then have 70% of the industrial clients who then further on develop and commercialize the technology internationally as a result of working with the National Research Council. Next slide. So to illustrate a little bit what I meant here with in terms of SMEs and D&D working together. So this slide here shows a little bit that we have on the bottom up the D&D operational requirements. We are thinking more at a TRL level from 6 to 9, not as probably early on as Duff mentioned before, 3 to 9. So we are a bit more advanced technology of a demonstration of technology. And we have, on the other hand, the SMEs, what they new innovative defense technology can do. And the tool is at Astra, the airborne platform to bring the thing together to make it quickly a successful product. Next slide. So talking about Ad Astra, what is Ad Astra? Well, Ad Astra, besides the acronym, what is elected is the Global 6500. And the question is, why a Global 6500? There's a number of reasons, obviously. We were looking for an aircraft with a certain range and altitude, and that means it's going to be jet-powered, Canadian. But also we were looking at in terms of what internationally, what is the real platform which is used internationally. And that is, as of this morning, I think we heard the announcement, NATO committed to buying 10 Global 6500 for the Saab GlobalEye, but it's around 40 approximately worldwide Global 6500 aircraft are used for special mission operations. That does not include the 6 aircraft D&Ds purchased just for VIP transportation. So that clearly the 6500 is a platform which is worldwide used for defense purposes. And I think that is important also to have a platform which is relevant for the Canadian defense industry to demonstrate the product on. Next slide. So, how do we convert a platform, this green aircraft we purchased, into a defense research platform? Well, we're doing this thing in 3 phases. And phase 1 is the acquisition of the green aircraft. This is completed. We purchased just before Christmas last year, a new Global 6500 and received this aircraft in the Toronto area. So that is completed. And what we are currently starting is the modification of this aircraft for defense purposes. So that means, and I will show you in the next slide, power requirements on the aircraft, additional electrical power, things like satellite communication, secure communication, military-grade communication, but also cooling systems down the road, mission seats inside. So this is all the modifications which is required to demonstrate defense technology. It will have, for example, a large belly pod where you can install radar equipment. It will have provisions for antennas. So this is all the what we call the baseline, the IOC, the initial operating capability modifications, which will then allow then the Canadian defense industry to demonstrate their technology. Phase 2 is that we are going to operate this aircraft potentially for around 6 months. So phase 1 is lasting around 2028. Phase 2 is then operating the aircraft for probably around 6 months, evaluating what we just installed, what was modified, and then also together with industry in the Department of National Defense between phase 1 and phase 2, saying, okay, what else? So we have all these things. What else do we need to install? What else is used for the industry? And that's where it comes in, where we work with D&D, but also with the Canadian defense industry and saying, okay, what else would be really, really important for you to have to see on this aircraft? Saying there's a number of things come to mind. So you have side cheeks, additional antennas, additional things. So that is where this space comes in, where we really make it then ready, come up with the idea to develop what we call FOC, the final operating capability. So the final operating capability will then be implemented following phase 2 in phase 3, and phase 3 will be completed by 2030 roughly. Next slide. So when I see IOC modifications, just a bit of a quick image here. That means it's going to have a nose boom. You see the large radome or a large canoe underneath with power and pneumatics and data. You have wing hard points on it for carrying external loads, secure military-grade satellite communications, delta fin, tail clamp extension, but also internally mission seats and large electric power capability, availability for all the instrumentations. So that is, there's additional modifications on the interior here. And so that is sort of IOC. For FOC, we don't see about others, which we haven't fully defined yet, but for example, cutouts, additional cutouts in the bottom of the fuselage, things like sonar buoy drops and others. So we're still working on this one, hopefully with industry. Next slide. Mention the timeline quickly. So we completed this, the green aircraft. We have the IOC requirements. We completed the IOC planning. So now it's 26 to 28, implementing IOC and developing FOC, and then 28 to 30, basically the FOC capabilities. One thing I would like to mention also in terms of question will be, how do we use this aircraft? We are deviating also what we did in the past. We are creating here a committee which decides, which is made up from D&D, NRC, and the Canadian defense industry members, what projects should ultimately go on the aircraft and be evaluated. So that means any great idea goes to the committee, and if it's suitable for the aircraft, has D&D purpose, the committee will select that this technology can be demonstrated to D&D, and that is going to be done not by NRC, it's going to be with NRC, the D&D, and the Canadian defense industry for presentation evaluation on the aircraft. So that means D&D can also use the aircraft for evaluating technology and saying, okay, how much is this technology really able to do? I think that is also a very important to point out. I think, next slide, I think. And that was Ad Astra. Thank you very much.
Perfect. Perfect. Thank you both for presenting some valuable information to the audience here today. Right now at this point, I'm going to open up the floor to anybody who wants to come on camera, ask a question, or if they'd want to come on, just ask by audio, or post your questions in the Q&A, which I'll be monitoring to ask the presenters. But to kick us off, I'm just going to start off with a quick question to the both of you. So going through the presentation and hearing you speak today, I see that, with you, Josef, with Ad Astra on those specific projects that you kind of want to dive into future, talk to the committee, right? Engage with them. The Drone Innovation Hub, I'm sure you have similar, but maybe you can walk through a little bit of the process of how some of the SMEs or academics may engage with you on these type of projects that they have and their ideas.
Do you want to go first, Joseph?
You go, Duff.
Okay. So on the Drone Innovation Hub, maybe 2 or 3 different ways to describe this. So as has been in the past, we're always open and interested for that direct communication to reach out and talk about the challenge and how we can help. Like that's sort of step number 1. Feel free to reach out to myself, and I'll look to drop in the chat here when Josef is talking. I'll put my email address in there, and also need to acknowledge that Nilufar Maradi is in the audience with us. She's our Director of Strategy and Business Development. I'll throw her email in there. She can thank me later as primary points of contact if you do have questions or want to explore work together in the future. That's definitely the most direct one. As we look at opportunities like Aurora Edge, for example, those will come out more in terms of like a call. So we'll coordinate with D&D to sort of define the scope, location, and all that sort of thing. And as soon as we have that laid down, we will look to make a call, an announcement to industry that, hey, in 8 months' time, we're going to be in, Cold Lake, Alberta. And we're going to have an experimentation event that's focused on this kind of technology, say ISR drone technologies and counter ISR drone technologies, for example. Provide a little bit of scoping information and then a point of contact to reach out on that. In those cases, in that kind of activity, we will apply a prioritization schema. That similar to Josef, we have a governance body that helps us develop these prioritization tools. And the same thing, it's defense, it's industry with NRC participation, so that we get a broader view of what our priorities should be. And then we would apply that prioritization to make sure that the top priorities get support going into that. So those will be on an ongoing basis. And through that national framework, we're looking to have like a long forecast window, so that ideally we set up success for industry so that a technology roadmap can be matched to the experimentation opportunities to help move things along. And then as other activities come along, like the Maple list, once we start doing that, having the capabilities to actually do those qualifications, it would be like a direct access type activity where a given company would reach out to the leads of the Maple list activity and coordinate for introduction of their system into that qualification process. Josef?
Thanks, Doug. Yeah, we have mentioned it briefly. We have this sort of this how we're going to manage and how we're going to this organizational structure. We are not quite done yet, to be honest, in the setup here. Open with you on this one. This is currently still being developed. We have the idea. We have sort of the governance structure set up. Now, in terms of the partners, we are working obviously with D&D. We are also working, that's part of today here, an ongoing engagement process with the Canadian industry to engage them in terms of this committee exactly. So the idea is AIC, for example, and other committees we are going to work with and trying to create these things. Unfortunately, we cannot have 580 Canadian companies part of this organization committee. That might not be the right way of approaching that, but certainly we need to have Canadian defense industry engaged, and that means not just the large companies, because we know that the exciting defense industry often comes from the small companies. So they need to be engaged on this one as well, okay? So it's not going to be just the multinational organizations, going to be the SMEs needs to be engaged. In terms of having their voice heard and being able to demonstrate their technology. One thing what we already achieved here is the Astra modification is being done in Canada. Now, this aircraft modifications, this is not new. They have been done, they are ongoing in the US with the Global 6500 for the US Army, for example. This aircraft is going to be modified, and the capability of modifying the aircraft is being brought back into Canada. to the extent possible. There's some items where we understand, that it cannot be done in Canada. We're not redeveloping the wheel here, but for the majority, to the extent possible, it's going to be done in Canada again. So that is already, I think, a huge success here, because other countries might be interested in modifying a Global 6500 for defense purposes, and now in the future, Canada will be able to offer this service. One thing also, probably Duff and I, we're working literally side by side here, a couple of meters away in our offices, but also Ad Astra is going to work with the drone technology. There's technology we're working together to make sure this is one technology, and ultimately that we can work as one demonstrator for, how we can work together. Loyal Wingman comes to mind, and others. I think that is also important to point out.
Oh, perfect. Thank you both for that answer. I'd also like to remind everybody, don't be afraid, raise your hand, get on the mic for asking questions for Duff and Josef. So we have our first question here. Ravi, you can come off mute and ask the question.
Hey, Duff and Josef, thank you so much for that information. I just have one question. Would definitely love and partner and work with you guys. Duff, I did contact you in the past, but I know you are very thin spread. So would like to get the contact you just mentioned for strategic partnerships and stuff like that, so that I can follow up and have a introductory conversation how our company Aerova can partner with NRC and work. So that's my only question. Thank you so much.
100%. And actually, we Nilüfer and I and her team, we were just reviewing outstanding connections, and as soon as I saw your name flag, I do have to apologize.
No problem.
We've been a bit we're
Absolutely.
getting lots of super positive feedback. It's just taking a bit of time to close the loop with everyone. Pardon me. Thank you for your patience. I put both my and Nilüfer's contacts in the Q&A because the chat's closed right now. Okay. So hopefully that's visible to everybody. Certainly we'll make sure it's in the, like, our emails are listed in the deck when we get it, when we provide it for release, but we'll definitely reach back to you. Looking forward to the discussion.
Thank you so much, Derek. And thank you so much for all your good work. And Stephen, thanks for arranging this. Thank you so much.
Thank you, Ravi. Thank you, Ravi. I have a question here for you that I wanted to pose. There are certain technologies that you're already starting to work on within the Drone Innovation Hub and other projects you're working on with Ad Astra. But have you noticed anything new, anything out of your realm that sparked interest within the Drone Innovation Hub and Ad Astra? And maybe there's areas where, some of the people on the call here can kind of start looking to innovate and fill those gaps.
It's a really good question. I mean, there's maybe a couple different things that come to mind, or a couple different ways to look at that. I think traditionally, when we've worked with D&D and when D&D's reached out to sort of explore an RFI, gathering information, it's been more directed and focused. And I think one of the things we're seeing and have been learning very rapidly through this process, that we need to keep an open mind as we ask for effects, because the technology involved could be outside of our awareness. And we do see in engagements where nobody's come to us with a time travel proposal, so it's not sort of that far out, but there's approaches that are being presented that had not been in our consideration that are very relevant and important to consider. And so as these opportunities come out for say an experimentation thing, we know we need to keep an open aperture, because the diversity of solutions, we do not want to constrain the diversity of solutions. But in terms of sort of specific technologies, I mean, obviously AI applications in sort of all dimensions, whether it's sensor fusion, information generation out of raw data, and decision making. Those are very much emerging technology areas of great interest for defense in particular. Yeah, I mean, I don't think I can necessarily sort of pinpoint other things. Perhaps maybe one other sort of large factor that we're seeing more and more of from defense is production capacity. And so there's lots of interest in procurement. But for those that have been involved, say with the Canadian Army and the Minerva activity, there's increasing emphasis on accelerating acquisition and having larger scale production. This is a piece that they keep speaking about. Certainly, it presents challenges in terms of the ability to rapidly generate large production capability without having assurance of funding for procurement from a procurement. And so that's something that certainly D&D is working with, and the new DIA organization. This is part of what they're considering right now, trying to make it more clear what the productions will be and how they'll be connected together, so that industry can respond to having those kinds of essential capabilities.
One thing I would like quickly to add on this one, what we see obviously is based on Ukraine is certain technologies, not just for drones, but also in terms of navigation denied, which creates quite a bit of interest. But also there's new aircraft. You have the Arctic, which is now in reach easily on a day trip kind of thing. The range on the Global 6500 is to take off from Ottawa, Toronto, you go to the Arctic area, you demonstrate your technology, and you come back on the same day. So you don't need to land. So that is one of the things I would like to add. The other thing is, while we are still currently working on Ad Astra, the aircraft modifications, I would like to point out that we currently have around 10 aircraft in a hangar. And yes, they are not the new aircraft, but we have been doing defense technology development with DRDC over a long time. Actually, DRDC used to be part of NRC. So we are working with them extensively and working with D&D already with the existing fleet and defense technology development. So meaning we don't have to wait until Ad Astra is ready in 2 years' time. We are already able to support the Canadian defense industry now.
Okay, amazing, perfect. I know we're being cognizant of time here. Josef and Derek, we do have 2 additional questions. Are you okay for a few minutes extra? Yeah, okay.
Sure.
So there is one question here from Armin saying that he is working for an AI company. They find the TRL maps don't go so nicely onto the AI systems. A lot of new plug and play sensors into an existing high TRL typically are suddenly drop 3 TRLs lower from ISED guidelines. So they're trying to understand in terms of more clarity, sufficient terms of feasibility or TRL and how you gauging the AI, sector in aerospace on the TRL scale.
Yeah, from the sort of the Drone Innovation Hub, we've to use the phrase, like we've walked this dog a little bit with our own technologies and derived AI technologies and its integration. I think largely when we get into this space, first of all, it depends on the application of AI. Like where is it within the system? Is it looking at perception systems and identifying objects, threats or targets or whatever, or is it decision making in terms of what the system should do next? Like it depends a little bit on where it's applied, but I think largely we understand the need for sort of initial data gathering to create data, especially if it's a machine learning algorithm. And so there's sort of that consideration. And then the validation space can be quite large. We definitely recognize that. And so as we look at different supports, I mean, we are looking to generate larger databases that are accessible to Canadians for developing AI algorithms. But that is not like in all domains. And so a bit of a discussion would be required there. But then as we look at sort of integration and testing and demonstration and all those sorts of things, we've traditionally found opportunities, not just within sort of dedicated, like a dedicated experiment, but taking AI systems, implementing it on platforms, maybe it's a surrogate platform, and supporting its development along with other activities we do. So try to find an economy and generate more opportunity for the validation or data gathering that might be needed. So I'd say ultimately would love to talk about the specific application and sort of map that out, but it's not like we don't want to transmit the message that, especially from an AI standpoint, that if you're not able to do this, we're not interested in working with you. We understand that this is a more complex space for sure.
Yeah, great. Thank you for that, Duff. We just have one more question here. Seems like we have a PhD student graduating, and he's kind of asking the question here, what are the type of job openings that you can foresee in the next 5 years for students, coming out of school, and academic involvement with those students, those PhD grads?
Yes, do you want to lead that off? I've been going first for a while. I don't want to steal your time.
Yeah, the National Research Council, we have a history of working obviously with what we call the best and the brightest kind of thing, and we are trying to recruit them from the academic institutions there. So, however, it depends very much on what area what we currently need, and what the availability of what we're having. So, meaning for Adastra, for example, we only have a very small number of additional positions we are hiring. On that side, there's a larger number of people. And the reason simply is because our aircraft is being modified in Canada. It's not a new technology where we don't need PhDs to modify the aircraft in itself. There's already relatively established. And no disrespect to PhD. I have a PhD in aerospace technology, so I highly appreciate that. But it really depends on the timing. We are, after all, a Government of Canada agency. So that means there's a process in place, there's the application process in place, and any kind of openings are posted on the Jobs Canada, I believe, website here. For Duff, I know he has a number of hiring actions currently ongoing. Pass to Duff here.
Yeah, for sure. Thanks, Josef. Yeah, so as we build these two new centers, the new lab, basically we started off pulling together from within the Aerospace Research Center our researchers and engineers already working in these domains, and sort of pulled them out of the existing labs to create the core of the new lab, about 25 people total in the two locations. Over the next couple of years, we're doubling that. And so like hiring actions are active. Canada.ca jobs is definitely the place to look, or follow myself, Charles Vidal, on LinkedIn. We repost all the hiring actions. We're looking for everything from, autonomy stack developers in perception algorithms, to our past traffic management experts. I think at the moment we have 10 hirings open. We've already been through 7 or 8, and this will continue on. And certainly, hopefully when, not if, the additional funding is unlocked, we'll be looking to, we'll almost double over the next 2 years, and then we'll look to sort of almost double again in the out years once that gets approved. So there is, this is a space where we need to grow, and so definitely keep an eye on that. Feel free to reach out to me, and I can point you to the site if you can't find it. And just a word on the academic collaboration. Although not sort of the specific focus within DIH, we do have been and continue to collaborate with academia. We're looking at different ways to help sort of expand and provide longer term collaboration, because we understand, like, a project for a couple of years is great, but it doesn't support academia enough. And so we understand this challenge, and we're working to resolve it. And then maybe one last word. Most of our researchers, or many of our researchers, are adjunct professors at universities sort of across the country as well. And so that's another way we collaborate.
Perfect. Thank you for that. I mean, we do have one more question if you're up for it, or we can stop it now. Okay. One person named Kanwar Johal He's asking any updates on air-launched effects program, timeline, and how it will be rolled out. For example, ideas challenge.
Yeah. So great question. That's right in my wheelhouse, something I'm actively, personally actively working. Air Force has identified air-launched effects as a priority for capability development. And it's starting out with the tactical aviation fleet, but going across all platforms, fixed wing and rotary wing. So we've been collaborating on air-launched effects for almost 2 years now. Those that watch Canada Buys and Sells, you will have seen a request for proposal going out for air-launched effects. And we got the proposals back. And this is an acquisition of high TRL air-launched effects capability that have already been cleared off of rotorcraft so that we can experiment with the capability to develop sort of knowledge and competence within the air-launched effect space to support industry. We're coordinating for challenge programs to create air-launched effects within Canada. And so those will be announced because they're not out yet. I can't really comment on it so much. But the intent is to sort of use the knowledge from that RFP process, small acquisition, to then turn that into a multi-tiered or multi-layered challenge program to create air-launched effects in Canada and link that all the way up to a procurement, given that the Air Force has such a high priority on it. So that is still in works, but that's the path that we're on.
Perfect. Well, thank you both. It's been a very informative session, and we thank you for all the insights you've provided to help our audience understand your opportunities and future. We will be sharing email addresses for Josef, Duff, and Nilofar in our follow-up after the webinar. I'd also like to extend our thank yous to everyone who's joined us today. We appreciate you taking the time out of your busy schedules to listen, participate, and engage. If you have any remaining questions, please feel free to email DAIR at any time, and we'll be happy to share those questions with Derek and Josef. But on behalf of the DAIR team, we thank you for doing this today, and we look forward to seeing hopefully all of you at future webinars or in-person events like our Dare to Innovate conference. So we hope to see you all there on October 29th. Have yourself a great rest of the day, everybody.
Thank you so much.
Thank you for your time.
Cheers.
Thanks, everybody.